Hey everybody, thanks for coming to the Unity Playground channel again. In this video we'll clean up this X scanner a little bit, make it look a little better, and then we'll proceed to the next part of trying to graph a function. So first of all, let's put this at the bottom, because what I'm really going to want to do is have this scan along the bottom to show us graphically where we are in the scanning process. Let's change the default step to 0.3. That was much faster and much more like what I'm looking for. Bouncing back and forth at that speed. And also I realized that when we look at this from the side, it looked kind of close, but actually when I look at it that close from that angle, it's not very close at all. This is at 25 approximately, and the X scanner is at 15. So let's see what if we put this at 23? Would this have any bearing on the end result? So it's still at -10. Hit go. That still looks okay. I think I'm going to make the main camera match this view again. And let's just check that out real quick. Yeah, it's a little bit misaligned. So 0, -10, 0. That should work. Not too bad. Okay, now let's make it a little less obvious, because that's not the focus of what we're going to be doing here. So let's make a new material and create material. I went to my materials folder. Transparent scanner. Okay. And then change it from opaque to transparent. And then let's change the albedo and turn the alpha down. I changed it to 82. Then drag that over the X scanner, and it goes almost invisible. But we can still see that it's moving back and forth there. Okay, next, let's make an object to represent the thing that's going to be, to represent the function. So I'm going to call it plotter, and I'll show you why in a minute. And let's put it back at 23 as well, and give it a position of -10 and 0. And then let's go to our scripts folder and make a new script for this. Plotter. Call it plotter and then open it up. Alright, in this script, the few things that we're going to do, I'm going to set the X value to the value of the X scanner. And then we're going to set the Y value to the value of the result of the function based on the X scanner. So we're going to need to be able to get the value of the X scanner at any given moment. Let's go back to that script and make an accessor for that. Public float get X value. Get X value. Return X value. That's it. But now the plotter instance needs access to the X scanner instance so that it can get that value. So one way to do that is public X scanner XS. And then when we go look at the plotter here, we attach the script. There we go. There's an X scanner. So drag your X scanner object into that empty field. Now let's fill in some of this code. Set the X value to the value of the X scanner. Well, we need the private transform T. T equals get component transform, and then float new pos equals T dot position. New pos dot X equals XS dot get X value. This is not a float, my bad. This is a vector 3. Okay. And then new pos dot Y equals, now it says the result of the function based on the X scanner. Well, what function? Well, for starters, we can just say math f.sign of xs.get x value, and then t.position equals new pos. Now let's see what happens. Excellent. That's exactly what I expected. So with that done, we've got a very basic graph calculator graphing the sine function and showing us live results of that. But there's some more things to do. Like I want to indicate where that plotter has been with a trail renderer, and I'll show you that in the next video or one of the next videos. But I also want to make the amplitude adjustable. So those are the kind of things we'll see in the next video. Thanks for watching this video, and I'll see you in the next one.